Okay, question 14. Oh, quite a lot of numbers in here, but it is really just a reverse chain rule, isn't it? So let's not get too stressed about the numbers. Let's just take our time and we'll go through the process. So the first thing I need to do is set up my integration. So I'm going to move this to the top. So I've got 2x plus 9. That just stays the same. I know the bracket here is going to be 2/3 because the 3 moves round. And it's going to be a negative because I changed the sign when I cross the line. So I'm going to integrate this between 9 and -4 with respect to x. Okay. At this point, I like to just, regular viewers will know, I like to just have a wee think, take a step back, and remember what integration and differentiation is. So if I've got 3x squared and I'm differentiating that, let's just remind myself, that's going to be 6x because I multiply them and take one away. Okay. If I'm integrating, say x squared, I'm going to end up with x cubed divided by 3, okay? Because I add 1 to the power and divide by the new power. So just remember that kind of, something that, I change that up each time. You might want to do something that's always the same, but yeah, just remind yourself what you're doing. We're adding 1 on and dividing by the new power. So here we go. If I add 1 onto this, I'll have my square ready. Between 9 and -4, so no c this time because we've got then defined points. If I add 1 onto that, I'm going to end up with a third. So 2x plus 9 stays where it is, and I'm going to have a third because I've added 1 onto the power. Now what was it again? It was add 1 onto the power and divide by the new power. Okay, so I need to divide by that new power. And that's where people go wrong. They forget the order and stuff. So make it nice and simple for yourself. Remember, and you can check that's right. You can differentiate and get back to that. Okay. Divide by the new power, and with the chain rule, or reverse chain rule, I need to remember that I'm dividing by the differential of the bracket, which is 2. So that's pretty good. That's a really good start there. Not a lot can go wrong if you just take your time and work it through point by point. Okay, so that is the same as dividing by 2/3. I'm going to imagine there's a little 1 up here. Okay, and on the side here, I'm going to say I've got 1 divided by 2/3. That's what that is, isn't it? 1 divided by, this would be 2/3. And when we do KFC, keep, flip, and change. So that's going to be 3/2. So I'm going to end up with 3, 2x plus 9 to the third, and I'm going to write the third like this. So yeah, the 3 goes at the front, and I'm going to write that as a cube root as well, and over 2. So I quite like doing this at sight. A lot of people will just be able to do the reciprocal quite easy, or they'll be able to do it in their head, whatever. But if you're not sure, just do a little sum at the side. KFC, keep, flip, change. Don't be confused when you're doing the dividing by fractions. Okay. So we've got that as our 3/2. I've written that out as a surd, so it's nice and easy. Now we're doing a substitution. So I've got 3. I'm doing the cube root of 2. And I'll just put this in a different colour so you can see it. And again, keep this nice and neat on the day because it will really help when you come to check it at the end if you've made a small mistake somewhere. Yeah, 3 cube root of 2, and this is -4 plus 9 all over 2. So nice and neat, neat's the key. Okay, so here I've got 18 plus 9, so it's going to be 27. So the cube root of 27 is 3. So I'm going to have 3 times 3/2. That's pretty good. And again, when you're doing the cube roots and stuff and square roots, numbers get big very quickly. So if you've got you're going to find if you do a root, it's going to be 1, 2, 3, 4 or something. It's massive. And likewise, other way around. Okay, so just be sensible. This is going to be -8 plus 9, so that's 1. So the cube root of 1 is just going to be 1 divided by 2. So look at that, isn't that quite nice? So I've got 9/2. Take away 3/2. So that's going to give me 6/2, which is the same as 3. And I'll just put it as an area. So it's 3 units squared. So, I mean, not a terrible question, but I think it's very easy to make an arithmetic mistake if you're not taking your time, really taking your time. And even then, some people could do that in one move. I didn't. I thought I'd just write it again. Just, don't stress yourself out. the more you've got going on in your head. And you're both stressed on the exam as well, so just take your time. You could even just written route 27 down, maybe, and then whatever. But yeah, just take your time. Make sure your integral is set up with a dx. Don't lose a point for that. And remember the chain rule here, okay? And I took a little space at the side to do the fraction, So not a bad question to finish off on, really. Yeah. So that is the end of the paper. So let's just have a wee quick look through what we did. It's been a while since I looked through this, but because I don't do it all at the same time. Straight line, PGE, don't lose marks for that. It's an excellent question where you're rearranging effectively to make x the subject and then calling it the inverse. And yeah, if you put the inverse into a function, you end up with x. So I was good. When we did some of this today, well, for me this was today, the chain rule, reverse chain rule, and further calculus. That's all at the front of your sheet. So there's a lot of equations there. I think they're good questions to do. We did the circle, which was effectively, that one was a straight line question. Good question. Logs, excellent marks to be had on logs. So I would really recommend you look at logs and wave function as well. Bit more algebra for this one. So we're looking at when you see curves and things like this, you're thinking put them equal to each other and factorize to find the point. It's very similar to straight line, isn't it? When you're saying when does this circle meet this line, you're subbing them in. So we did a bit of that. We're looking at m tan theta. That's something that gets people, so don't forget you need to rearrange to be m is equal to, so y is equal to mx plus 3 to get the gradient, and then you're looking at m tan theta to get the angle. Okay, be wary if it's a negative. I think I was chatting about that. And yeah, different your integration here, that's your differential equation. So you integrate it and then you sub in the point to find c. So when you see something like this, when you see you're having to integrate and it tells you a point, that's very much the hint that you're trying to solve for c. So we went through quite a lot there. There were some log graphs. Remember, for graphs, if it's next to the x, you're doing the opposite of it. So 2x, you're halving the x values. Everything else you're doing what it says on the tin for the y's. So for example, +1, you're adding 1 to y. So there about that. You see a right angled triangle with this, you should be thinking it's going to be your expansion, your identities. You do Pythagoras to work out the missing side. Yeah, and we just did the integration there. So I think there's definitely a lot of repetition. In fact, we just finished off. There was a wee problem solving question. That's quite a good one actually about polynomials. But yeah, there's a lot of repetition in these questions, and it's getting that list of topics and then the kind of potential questions out of each of them. And I think there's about 12 topics and about 3 kind of questions. There's a few curveballs you can throw either way, but that's kind of it. So just get that down. And I think wave and log have got a lot of wave, log, and further calculus. There's a lot of easy marks to be had there. I think sometimes with like straight line and stuff, it should be the bag straight line, but there's a lot of chances to make arithmetic mistakes or algebraic mistakes. So yeah, I think some of the harder stuff, or the perceived harder stuff, like logs, wave, further calculus, can actually give you a lot of marks for a bit less working and sometimes a bit less thinking, because they can be very prescriptive, But the differentiation integration questions, sometimes they're tied into some contexts which are a bit crazy, and but yeah, I'm just going to riff it now. So look, I hope that was helpful, and if you can take anything from working through this, it's just taking your time. Try to make it as neat as possible. You see I've got lots of little sketches everywhere, lots of little drawings and annotations. I would definitely suggest you do the same and make the marker's life easy. Underline your answers, lay it out well. Really feed to them what you've got. So if you make a mistake, it's clear what you've done. And don't forget all those little things. Integral dx. Your plus c. Dy by dx is 0 for a stationary point. All those little things. Make sure they're going in so that they know what you're thinking. All right.